friends, welcome to my channel. So in this series of landing aerodynamics, we are discussing about climbing flight. So in the previous video, we have solved one numericals based on the data. So by using the same data, so in this problem, in this class, we will find out the maximum angle of climb. So in the previous video or in the previous class, we have solved that means we have found the solution for maximum angle of climb. So in this video, so in this lesson, let us discuss about or let us find the value of maximum angle of climb. So for finding the maximum angle of climb, the same data whatever we used in the previous problem, the same data we are taking. So we just considering the executive jet. For that, okay, we have the drag polar, so CD equal to 0.02 and plus 0.05 CL square. So the weight is 44,480 Newton and thrust is 8,900 Newton and wing area, so 18.5 meter square. So for this given data, we have to find out what is the maximum angle of climb. So okay, so what we need to understand here, thrust is given. So weight is given, thrust is given. So it means the thrust is constant. So that means the engine is producing a constant thrust. So because this value can be taken as constant. So by considering this condition, we can solve this problem. That means even in our previous discussion, we have just found this. Even we had this. So that means. In our this diagram also we had it. So that means, so this is okay, nothing but we know this is the total drag. Okay, so then this is drag, or we can say thrust. So total drag, okay, so where it will be maximum. Okay, so this is nothing but velocity. So okay, in this suppose if you are having constant thrust, so our thrust will be it's something like this. The thrust line is something like this. So the maximum this T by D, this is the this, okay, we can just say this is the maximum T minus D. Okay, so once we know this maximum T minus D, then we can find out the by using this condition we can find out maximum angle of climb. So that means when the thrust is constant, that means when the thrust is constant, so this is thrust, okay. So this is constant, so this is nothing but we can say total drag. So this is nothing but total drag or drag. Okay, so if this thrust is constant, then for that, okay, we are obtaining, so what is the T minus D max. So this condition when it can be obtained, so that is when the drag is minimum, that time we can obtain this maximum. So that is the idea. So when the drag will be minimum, so when the drag will be minimum only when the that means the minimum drag conditions. So by using the minimum drag conditions, then we can obtain this T minus D max. Okay, so okay, for when the thrust is constant, then we can find out the T minus D max by using the minimum drag conditions. So let us just go for the solution. The solution is we can just use this. Okay, so we know the sine theta. So sine theta equal to T minus D by W. Okay, for the from the rate of climb derivation. So sine theta equal to T minus D by W. So suppose if you take it as this is maximum, if this is maximum, then now we need to go for minimum drag condition. So that is the idea. It means T by W minus D by W. So it means this is we consider it okay, T by W minus this is okay for the steady level flight, we just put D by L. So further it can be replaced, that means T by W minus CD by, in the coefficient form we can write. So now this has to be maximum. Okay, so this is maximum, it means this has to be minimum, this value has to be minimum. So then only our what to say, this sin theta maximum angle of climb can be found. Okay, so this is okay, when it is minimum we can write T by W minus 1 by L by D max. So this is a minimum drag condition, so we are using. So when the minimum drag condition we are using, then we can write T by W minus 1 by L by D max. So we can use this condition, or okay, we can use this formula, then we can find out the maximum angle of climb. So okay, now so let us just substitute the values, or okay, first let us find the L by D max. So L by D max we can just find out by using CL minimum drag by CD minimum drag. Okay, so CL minimum drag we know, okay, that is nothing but square root of CD naught by K by CD minimum drag to CD naught. So we know we have the data. So by substituting this data we can find out what is. So L by D max, okay, equal to square root of this is CD naught by K. So square root of CD naught is nothing but 0.02 by K, 0.05 by 2 CD naught, twice into CD naught is 0.05. Okay, so this is that means this ratio comes around, this ratio we can just say, this ratio L by D max comes around, by after doing the calculation this value comes around 15.81. so this is 15.81. okay, so now we got the L by D ratio, or that means maximum L by D ratio, we can substitute in this formula. Okay, so because yeah, now let us substitute the value to find the maximum angular climb. So okay, so sin theta equal to, yeah, so sin theta equal to this is T by W, yeah, T is nothing but 8,900 by 44,480 minus 1 by L by D maximum L by D ratio, so 1 by 15.81. okay, so then theta, so we can just say this is okay, theta max. So from this we can find out theta max. So theta max equal to, this value comes around okay, this value comes around, we can just get the value 0.1367. so it is 0.1367. then theta max equal to sin inversal 0.1367. okay, so theta max equal to just 7.86. This value comes around 7.86 degree. So theta max equal to yeah, 7.86 degree. So this is okay. Now we got the maximum angle of climb. So we got the maximum angle of climb. Okay, for this maximum angle of climb, what is the rate of climb? So that we can find out. Okay, so let's find the velocity, then to find the rate of climb. Okay, so maximum angle of climb, you got it. Yeah. Okay, so velocity maximum, that means velocity for this minimum drag conditions, we can find out v yeah, equal to this is okay, we can just say velocity minimum drag, because we are going to use the CL minimum drag only for finding this 2 W by S by rho CL minimum drag. Okay, so in this we can just substitute the values. Yeah, so 2 into W 44,480 by yeah, rho, okay, S we nothing but 18.5 into rho 1 point, sea level condition we consider. So then CL minimum drag, so CL minimum drag nothing but square root of CD naught by K, so that value, okay, 0.632, so 0.632, yeah. Then this is velocity minimum drag comes around, it's nothing but it comes around 78.5, this is 78.5 meter per second. Okay, so we got the theta max, and then yeah, now we can find out what is the rate of climb. So the rate of climb equal to, so rate of climb equal to, for the minimum drag condition, so V sin theta, so V is nothing but 78.5, so 78.5 into sin theta 0.1367. okay, so the rate of climb comes around by doing this calculation, the rate of climb comes around yeah, we have to this is okay, we are getting around 78.5, that is equal to yeah, so in feet, okay, we can say 35.24, it is 35.24. Yes, anyway, this value will be lesser than that. Okay, previously we have got, okay, so this will be, okay, in feet, this is feet per second. Okay, so this is okay, very small, that means this value will be, okay, now we got the value. So we got the theta max and rate of climb for the maximum angle of climb condition. So we can just find one more thing, one interesting okay, this, that is nothing but this value is around 7 point, that means this is 9 point something. Okay, so 9 meter per second. So okay, so anyway, what we have to understand, we know from the that means from the given graph, we know from the graph says that that means this is okay, rate of climb, this is nothing but velocity. So if you draw this graph, okay, this graph used to be yeah, we used to have something like this. Okay, so okay, so here this is what, okay, so maximum angle of climb, just we used to find it here. So if you draw the tangent to this graph, this is okay. Yeah. So this is what, okay, this angle. So this angle only we just say maximum theta max. Okay, so then the velocity here we should get this. This is the velocity for maximum angle of climb. So v theta max we can say. Then we also can find the this another one, rate of climb max from this. So that is nothing but with respect to this point. So just we can draw the, yeah. So the velocity, okay. So this velocity is okay, is something like this. This is the v rate of climb max. Okay, so this is nothing but rate of climb, maximum rate of climb, this point. Okay, so we from this, okay, the angle of climb for this will be smaller. So this is okay for the maximum rate of climb condition. The angle of climb is smaller. Okay, so this is what we can say theta for maximum rate of climb condition. So from this we understood that for the maximum rate of climb the velocity will be higher. Okay, so that is what we got it. We got it in the previous calculation. From the previous calculation, this comes around 13 point something. So this value used to be, this value came around, okay, 13 point, 13.5 or something. Okay, meter per second. Then now, okay, the maximum rate of climb also we know. So the from the previous calculation. So that was okay. We got it. Then another one, okay, for the maximum angle of climb, the velocity. So now we are getting around 9. So this is okay. So obviously it is okay matching with our graphical representation. So for the maximum angle of climb, the velocity will be smaller than the maximum rate of climb. So that is what we have to understand from this calculation or from this example. I hope, okay, this problem gives some idea about how to find out the maximum angle of climb and maximum rate of climb. So